Okay, very good evening, Sarvesh. कनेक्टिव्हिटी इशू आहे, स्टिल कनेक्टिव्हिटी इशू इज देअर. आवाज येतोय व्यवस्थित? स्टक होतोय? इज वॉइस क्लियर, सर्वेश? Okay, so start करूया session. Okay, so this is our exercise 7.11, which consisting of 19 actual questions and 2 MCQ. So let's start with the first one. First question is, four to five is our target. Yes. Okay, so whatever is the question, let I is equals to integral 0 to pi by 2 cos square x dx. Okay, assume this as a. Now which property can we apply here? So make the integral a simple one. So I have the formula. Now properly see that 0 to a f of x dx is equals to 0 to a f of a minus x dx. Right, we have this property that we substitute difference of limit and our variables, upper limit and variable. Okay, so by using this we can say that our I is equals to 0 to pi by 2. Now actual function is cos square, so cos square, and what is variable substitution we need? Variable substitution we need upper limit, that is pi by 2 minus x dx. Okay, then from this we get I is equals to 0 to pi by 2, and cos pi by 2 is sine. Okay, so sine square x dx. So this is we get. So calling this as equation number 1, and this will be as 2. Now next move, add 1 and 2, 1 plus 2. So 1 plus 2 we get. Obviously LHS is also going to add. Okay, so I plus I is equals to integral 0 to a cos, not 0 to a, it is pi by 2, 0 to pi by 2, 0 to pi by 2 cos square x dx plus integral 0 to pi by 2 sine square x d. Right, then I plus I is, this will be 2i here, taking the common limit 0 to pi by 2. So this will be cos square x plus sine square x dx. Therefore 2i is, now this is nothing but the identity 0 to pi by 2, so this will be 1 dx. That's it. Now it will be calculated as so simple. So 2i is equals to, now integral of 1 is x and limits from 0 to pi by 2. So further this can be written as pi by 2 minus 0, pi by 2 minus 0, and this 2 implies here. So I is equals to, 2 इकडे multiply, regular divide, so pi by 4. That's it. Clear? This one is quite simple. Take the screenshot of this one, and then we will start with the next one. Is in doubt regarding this question? इथे फक्त एक लिहून द्यायचं, वी हॅव प्रॉपर्टी और वी नो, दोनपैकी कुठलाही एक शब्द टाकला तर चालेल. So question number 2 is 1. So same property परत वापरायची आहे. बघूया. 0 to pi by 2. So let I is equals to 0 to pi by 2 under root sine x upon sin x plus under root cos x dx, calling this as equation. Okay, as we know, or we know that 0 to a f of x dx is equals to 0 to a f of a minus x, right? We have this property just used earlier. Now by using this I is equals 0 to pi by 2. आता जिथे जिथे x आहे तिथे पाय बाय 2 मायनस एक्स अप्लाय करायचं. ठीक आहे, हे थोडंसं मोठं होईल. साइन पाय बाय 2 मायनस एक्स अपॉन अंडर रूट साइन पाय बाय 2 मायनस एक्स प्लस अंडर रूट cos pi by 2 minus x. करना थोड़ा सा. Calling this as equation, sorry, not this one, याच्यानंतरची स्टेप येईल 2 म्हणून. So this implies I is equals to integral 0 to pi by 2. Now what can I write here? Sin pi by 2 minus x is cos x. Now obviously it is in root upon under root, this will be cos x plus this will be sin x. Dx, equation 2. Now check what we done actually. We make the denominator equal, sin x plus cos x plus sin x. Okay, now same thing again, 1 plus 2. 1 plus 2 lies, obviously I plus I is equals to integral 0 to pi by 2. Now equation 1 is under root sine x upon under root sine x under root sin x plus cos x dx plus 0 to pi by 2 under root cos x upon cos x plus under root. Okay, now I plus I is obviously 2i, common integral 0 to pi by 2. Now check sin x plus cos x under root sin x plus under root cos x upon same denominator under root sin x plus under root cos x dx. Now this whole will be get cancelled. Okay, whole will be get cancelled. 1 1. Therefore what will be left with 2i 0 to pi by 2, same problem as earlier. So therefore 2I is equals to x limit from 0 to pi by 2, which can be calculated as pi by 2 minus 0, which can be further written as I is equals to pi by 4. That's it. Check that. Same thing again. Okay, let's do for the next one. Now question number 3. आता बघ, क्वेश्चन नंबर 3 मध्ये सेम प्रॉपर्टी यूज करायची आहे मला. सेम 0 टू पाय बाय 2 दिसतोय, त्याच टर्म्स येतील, त्यानंतर परत कॅन्सलेशन येईल आणि 1 होईल. सेम फॉर क्वेश्चन नंबर 4 ऑल्सो. तर या दोन्ही क्वेश्चनमध्ये सेम प्रोसिजर आहे आणि यांचं चौघांचं आन्सर जे आहे हे पाय बाय 4च राहणार आहे. सो डू यू वॉन्ट थर्ड और फोर्थ वन ऑफ देम? चौघांचं हे पहिले 4 जे आहेत, पहिले 4 क्वेश्चन, या चौघांचा आन्सर पाय बाय 4 सेम प्रॉपर्टी यूज करायची आहे. नाउ चेक वेदर यू वॉन्ट वन ऑफ देम और नॉट, और वी गो फॉर द क्वेश्चन नंबर 5. थर्ड आणि फोर्थ मधला कुठला हवा आहे, कारण की सेम प्रोसिजर आहे, सेम प्रॉपर्टी यूज करायची आहे आपल्याला. थर्ड नीडेड. ओके चला ठीक आहे. Okay, same procedure I will follow again. So I is equals to, not I, let I is equals to 0 to pi by 2. Same problem again. Find raised to power 3 by 2 x dx upon sin raised to power 3 by 2 x plus cos raised to power 3 by 2, calling this as equation number 1. Next we have, or as we know, integral 0 to a f of x dx is equals to 0 to a f of a minus x dx. ठीक आहे, ही प्रॉपर्टी परत याला अप्लाय करायची. हाउ दिस कॅन बी रिटन ॲज I is equals to 0 to pi by 2 sin raised to power 3 by 2, and x can be written as pi by 2 minus x divided by sin raised to power 3 by 2 pi by 2 minus x plus cos raised to power 3 by 2 cos raised to power 3 by 2 pi by 2 minus. Then this will be written as I is equals to 0 to pi by 2. हे होणार नाही. I is equals to 0 to pi by 2 sin raised to power, no, sorry, not sin raised to power now. आता Sine pi by 2 is obviously cos, so this can be written as cos raised to power 3 by 2x upon sine, again cos raised to power 3 by 2x plus, and cos will turn to sine raised to power 3 by 2x dx, and calling this as equation number 2. Now check that again, denominator of both equation is same, so 1 plus 2 implies, so I plus I is equals to integral 0 to pi by 2. What is the first one? Sine raised to power 3 by 2 x dx upon sine raised to power 3 by 2 x plus cos raised to power 3 by 2 x, dx already written, plus 0 to, okay, there will be slight interruption again of connectivity. तर परत cos raised to power 3 by 2 x plus sine raised to power 3 by 2 x. Okay, now check that again, denominator is same, so I plus I is 2I. Then common denominator, common limit 0 to pi by 2, then sine raised to power 3 by 2 x, now whole term get cancelled as the previous problems have, so 2I is equals to integral 0 to pi by 2 1 dx, which have the integral value of x 0 to pi by 2, which can be written as pi by 2 minus 0. So finally I is equals to pi by 4 again. That's it. So अगेन कनेक्टिव्हिटी डिस्टर्बन्स आय थिंक. ओके, तर सर्व समजलेलं आहे, काही स्टेप मिस झाली आहे तुझी. इज एव्हरीथिंग अंडरस्टूड? समजलं, ओके ठीक आहे. So now question number 5. Okay, next question. आवाज येतोय सर्वेश व्यवस्थितपणे? ओके. माझ्याकडे जी स्क्रीन आहे त्यामध्ये स्टक होताना दिसतंय मला. चला ठीक आहे. सो नेक्स्ट क्वेश्चन. आता बघ, हा क्वेश्चन थोडा ट्विस्ट आहे कारण की याच्यामध्ये नॉर्मल फंक्शन नाही दिलेला आहे, मॉड फंक्शन दिलेलं आहे. ठीक आहे. तर -5 टू +5 ॲक्च्युली आपण ए टू बी एक लिमिट घ्यायचो. ठीक आहे. आठवा आता, -a टू +a जर असेल तर त्यामध्ये आपण किंवा ए टू बी जर असेल, फॉरगेट अबाउट द मायनस, ए टू बी असेल तर त्यामध्ये आपण एक फंक्शन डिस्क्राईब करायचो, प्रॉपर्टी डिस्क्राईब करायचो. ठीक आहे, मी डायरेक्ट प्रॉपर्टीज सांगतोय. ॲक्च्युली ती परत लिहावी लागेल. पहिले तर मी हे अज्युम करून घेतो आहे की जो फंक्शन आपला दिलेला आहे ना त्यामध्ये एक बिटवीन व्हॅल्यू कोणती तरी घेऊन घेऊ आपण. ठीक आहे. सो ॲज वी सी दॅट, वी कॅन सी दॅट our function is in mod, so we will take x plus 2. So we have two values, either negative or positive. So less than 0, x plus 2 is less than 0 on कुठून कुठपर्यंत -5 to -2 हे अज्युम्ड इंटरवल आहे. ठीक आहे, आवश्यक नाही आहे की आपण हेच घेतलं पाहिजे. ओके. आणि असं पर्टिक्युलरली -5 to -2 का? So when I put -2 for x, -2 plus 2 becomes 0. ठीक है, and that's why I choose the -2. So x plus 2 is less or equal to 0 on -5 to +2, and x plus 2 is greater or equal to 0 on -2 to +5. Check that. Okay. या इंटरवलवर आपला फंक्शन जो आहे एक तर लेस दॅन 0 आहे किंवा ग्रेटर दॅन 0 आहे. दॅट इज अवर मिड व्हॅल्यू. आपण म्हणायचो ना ए टू बी, मग कोणती तरी एक व्हॅल्यू घ्यायची मदत, तर आपण सी टाकायचो. तर इथे आपली लोअर इंटरवल आहे -5, दॅट इज लोअर लिमिट इज -5, अपर लिमिट इज +5, अँड वी नीड दॅट बिटवीन व्हॅल्यू. सो बिटवीन व्हॅल्यू इज -2. ओके. एवढा कॉन्सेप्ट समजलेला आहे बघ. एवढा कॉन्सेप्ट समजलेला आहे. सिलेक्शन ऑफ दिस टू इंटरवल इज क्लिअर. या दोन इंटरवलचं सिलेक्शन, वाय आय चूज दीज टू, -5 to -2 and -2 to +5. Are these two interval clear? ओके. चला समोरचं बघूया आता. बस आता इथून आपल्याला प्रॉपर्टी यूज करायची आहे. सो वी हॅव द प्रॉपर्टी a to b, not 0, a to b f of x dx can be written as a to c f of x dx plus c to b f of x, right? So our integral can be written as I is equals to, so -5 to -2, -5 to -2, and remember -5 to -2 पर्यंत आपला इंटिग्रल कसा आहे, either 0 or negative, that is less than 0. So that's why I will write it as minus times x plus 2 dx. ओके, हे लक्षात ठेवायचं, इथे ही चूक होते. देन -2 to +5 पर्यंत आपला इंटिग्रल कसा येणार आहे, ऑब्वियसली पॉझिटिव्ह. सो x plus 2 dx. Now apply the simple integral term, that's it. चला I is equals to, so integral of this one is taken minus as a common, so x plus 2 चा integral x square upon 2 plus 2x, I can write it properly, x square upon 2 plus 2x, integrating limits from minus 5 to minus 2, plus here same x square upon 2 plus 2x, limits from minus 2 to plus 5. Okay, now solve it, that is on simplifying the terms. I is equals to, minus will be as it is, minus 2 चा square upon 2 plus 2 into minus 2x. Now minus times minus 5 चा square upon 2, minus 5 चा square upon 2 minus 2 into minus 5. This will be the first integrating limit. Then next, this will be quite simple, 5 square upon 2 plus 2 into 5. Then next, minus times minus 2 चा square upon 2 minus 2 into minus. This simple calculative term. Now solve this. दिसताना एखादा प्रॉब्लेम जरी खूप कठीण वाटत असलं तरी ते सॉल्व होताना खूप सोपं होऊन जातं बाय यूजिंग दिस प्रॉपर्टी. फक्त प्रॉपर्टीचा कॉन्सेप्ट अप्लाय करता यायला पाहिजे. देन नेक्स्ट, नाउ सॉल्व दिस. I will keep this minus sign as it is. Minus 2 चा square obviously 4. 4 upon 2 is 2. 2 into minus 2, that is minus 4. Then next term, minus 25 by 4, and this will be plus 10. Okay, next plus here 25 by 2, हे पण 4 नाही होणार. So 25 by 2 plus 10, again minus 2 चा square 4 आणि upon 2, that is minus 2, and here minus 2 into minus become plus. पॉझिटिव्ह आहे आणि ही एक हा एक मायनस साइन आहे, तो मी आतमध्ये परत इंट्रोड्यूस करून देतोय. सो I is equals to, पहिले याला सॉल्व करून घेऊ. 2 plus 10, 12, 12 minus 4, that is 8, 8 minus 25 by 2 plus इकडे 25 by 2 as it is, and the next term is 10 minus 2, 8, 8 plus 4, 12. Then next is equals to, introducing minus inside, minus 8 minus into minus become plus 25 by 2 plus 25 by 2 plus 12. Now 4 minus 8 is obviously it is 4. I will write little closer terms, minus 8 plus 25 upon 2 plus 25 upon 2 plus 12. So at the end 12 minus 8, 4. 25 plus 25, 50 by 2, that is 25. 4 plus 25 is 29. That's it. The value of I is equals to 29. Okay. Now it's time for screenshot. Okay, take this. Is it clear, Sarvesh? Okay, done. Let's move for today's last problem. आजच्या सेशन मधलं. So now which question you want again? 6 is same of 5 अगदी 5 सारखं 6 आहे. कधी 0 होणार, दॅट इज ऑन 5. Okay, question number 7 directly you needed. Let's start for 7. Okay, so let I is equals to 0 to 1, x into 1 minus x is to power n dx. Write properly. X into 1 minus x is to power n. सो अगेन सगळ्यात पहिल्या क्वेश्चनला जी प्रॉपर्टी आपण यूज केली होती ना, तीच प्रॉपर्टी परत वापरायची याच्यामध्ये. We have, or as we know, integral 0 to a f of x dx is equals to, what will we get? 0 to a f of a minus x dx. So our integral I becomes, I is equal 0 to 1 obviously. Now what is x? जिथे जिथे x आहे तिथे 1 minus x apply. 1 minus x, 1 minus x, sorry, not 1 minus, 1 minus into in bracket 1 minus x raised to power n dx. So this will be I is equals to 0 to 1, 1 minus x as it is. After introducing this minus 1 plus x raised to power n. So the next term we get I is equals to 0 to 1, 1 minus x. Now plus 1 minus 1 is get cancelled, x is to power n d. So now multiply these terms. So introduce x is to power n inside. So here I is equals to 0 to 1. So after introducing x is to power n inside, to power n into x is to power n dx, that is I is equals to 0 to 1 x is to power n minus this is nothing but 1, so we can write this at x power n plus 1, right? And that's it. Now distribute I is equals to 0 to 1 x is to power n dx minus 0 to 1 x is to power n plus 1 dx. Integral of these two terms can be written as x is to power n plus 1 upon n plus 1 with limit 0 to 1 minus x is to power n plus 2 upon n plus 2 with limit 0 to 1. That's it. Now apply the limits. I is equals to, so value of x is 1, so 1 raised to power anything, what we get, x is to power, that is 1 raised to power n plus 1 is 1 upon